Welcome to this video in Chapter 11, Section 1, Right Triangle Trigonometry. Mr. Brack and I hope that this lesson is all reviewed to you other than one little component from your geometry days last year. You talked about right triangle trigonometry and used it quite a bit in geometry last year, or Math 2 as it might be called. But we are going to introduce three new trig ratios, gasp, that you did not cover last year, or at least I don't remember covering them last year. So that will be a little bit of a new part of the lesson today, but spoiler alert, they're just reciprocals. So trigonometry is the study of the relationships among the sides and angles of a right triangle. So let theta is a Greek letter that's often used for an angle measure, theta. If you don't like theta, you could use x. Sometimes alpha, beta are used. So don't make a big deal. It's just a variable, it's an angle. The measure of an acute angle of a right triangle is theta. So really important when you're doing right triangle trig that you know how to identify the opposite side, the opposite leg to theta, the adjacent leg to theta, and what the hypotenuse is. So we have a right triangle. Here's our little right triangle. There's our right angle. And here's our theta, this acute angle over here is theta. Opposite of theta is the leg opposite. How much more can you explain that? Opposite of theta is that leg, and it's a leg, not the hypotenuse. Hopefully you remember what the hypotenuse is. The longest side of the right triangle is the hypotenuse, the side opposite of the right angle. So there's that word opposite again, opposite of the right angle. It is the side that's not touching the angle. The angle's formed by two sides. This angle's formed by this side and this side. So the opposite side is not touching or forming the angle. So similarly, this hypotenuse is opposite of this right angle. The right angle is formed by these two line segments. Opposite of that is the side that is not used to form the angle. Okay, let me actually erase some of this so you can read. So opposite of the theta angle is this side. The hypotenuse is the longest side. So that means the adjacent leg, the adjacent side. The adjacent leg to the angle forms the angle, or forms part of the angle, and then the hypotenuse forms the other side. So it's really important that you can identify which side is which. So let me just switch it up a little bit. What if our angle was up here? We'll call it alpha. Now the opposite side changes. The opposite's down here. It used to be the adjacent side of theta. Now it's the opposite side to the angle alpha. And then the adjacent leg, the adjacent side to alpha would be right there. So it's really important that you can identify which one's which. Now there's a relationship between the angle and the side lengths in a right triangle. And these different relationships are called trig ratios. You might recall from your geometry days that we have similar triangles, for instance. So we have this one triangle right here at the top that you see. If I drew a line right here, this green triangle is a similar triangle. It's similar by angle-angle similarity. They have the theta angle congruent, and they have the right angle congruent. And that's all that you need for angle-angle similarity. These triangles are similar, so their sides are proportional. So if, for instance, this green side is a length of 3, and this bottom green side is a length of 4, then maybe this whole thing would be proportional to that. Maybe we'll do a scale factor of 2, so it would be at 8. And this whole side would be 6. So notice the ratio. Let's do the opposite compared to the adjacent side. For theta in the green triangle, the opposite would be 3 over 4, 3/4. That ratio is the same as the ratio of opposite of theta in the bigger triangle, 6 over 8, 6 over 8. Since those ratios are the same, They're both equal to 3/4. We can use those ratios to determine what the actual value or measure of the angle is, what theta equals. And to do that, we use what are called trig ratios. So we have the sine ratio, sine, S-I-N-E. Sine of theta is opposite, which is over here, divided by hypotenuse. Cosine is defined as the adjacent side divided by the hypotenuse. And the tangent ratio is defined as the opposite side divided by the adjacent side. And the mnemonic that I'm guessing you'll remember is, can anybody say it for me? Anybody? Anybody out there? So the sine is opposite over hypotenuse. So that's the opposite hypotenuse and sine ratio. Whoops, try to circle that S there. So ca, C-A-H, and then toa. SOHCAHTOA. And that's been used, that mnemonic device has been used years and years and years to remember that sine matches with opposite hypotenuse, cosine, ca, matches with adjacent and hypotenuse, and tangent matches with opposite and adjacent. My note here is an important one. Sine, cosine, and tangent always have an angle measure or variable with it. So the problem that I'm referring to, some students like to write it like this: sine equals 3/4, and sometimes even how we talk as not as precise as we should be. We should have sine of an angle equals 3/4. If you write it as sine equals 3/4, you'll get confused. What are you actually solving for? Here you can see sine theta equals 3/4. That's a theta, believe me. Not that it would be actually 3/4. It might be 3/5, but anyway. Sine theta equals 3/4. You could solve for theta. Moving on, really the one new part of the lesson that you probably haven't learned before is this part, the reciprocal functions. Remember, a reciprocal, if you have 2/3, the reciprocal of 2/3 is 3/2. So these reciprocal functions will tally up. Now we have 6 trig functions, not just the SOHCAHTOA, 3, but we have 3 reciprocals of those. So cosecant is abbreviated CSC, and it is the reciprocal of sine. You have to be careful here because the co might make you think it's the reciprocal of cosine, but it's the reciprocal of sine. And notice what it is. It's hypotenuse over opposite, just the reciprocal of opposite over hypotenuse. Secant is abbreviated SEC, and that's the reciprocal of cosine, and that is the, as you can see here, cosine is adjacent over hypotenuse, and just do the reciprocal of that, and you get secant, theta. And then cotangent is abbreviated COT, cot. Cotangent is the reciprocal of tangent. So these are the reciprocal functions. And then another topic that you have learned before, angle of elevation, angle of depression. Let's say you have ground here. These are going to be helpful in word problems. Here's the ground. So you have a little person down here. They're really small because they're far away. And they're looking up at something over here. Let's say a tall tree. You want to know maybe how tall the tree is. Maybe you want to know what angle down here is formed. This angle that's formed down here is called the angle of elevation. Angle of depression. Let's say we have the ground right here. Let's say we have a mountain or a building of some sort, and your person's right here, and they're really small because it's far away. And that person is looking down here at something on the ground, something over there, for the angle of depression, the angle of depression is congruent to the angle of elevation. So you have to extend their line of sight this way, and their line of sight with this dotted line that they're looking down, this is the angle of depression. So notice, if you remember alternate interior angles, alt-int from geometry or math 2, alt-int angles, alternate interior angles are congruent when you have parallel lines, and these two purple lines here are parallel. So the angle of elevation, the one down here, is congruent to the angle of depression, the one up here. The main thing you have to be careful about is not to say this angle. That angle doesn't have a name. That is not the angle of depression. Not the angle of depression. Okay, so let's check out some examples here. This first question, we're not going to be solving anything. We're just going to be stating, making sure you get the idea down, stating the 6, notice it says 6 trig functions for angle theta. Theta's right down here. So we have sine of theta equals cosine of theta equals tangent of theta equals. We also have the 3 reciprocal functions. The reciprocal of sine is cosecant, CSC theta. And then the reciprocal of cosine is secant theta. And then cotangent theta. So the reciprocal, sine theta is opposite over hypotenuse, so that would be 3/5, and that's it. We're just getting used to writing them, not solving anything. Cosine theta would be 4/5. Tangent theta would be 3/4, opposite over adjacent. Now the reciprocal functions, you could memorize them, that cosecant is h over o, or you could just figure out sine and then do the reciprocal of that. That's probably the faster way. That's the way I like. So the reciprocal of 3/5 is 5/3. Reciprocal of 4/5 is 5/4. Reciprocal of tangent, theta equals 3/4. Reciprocal of 3/4 is 4/3. And thus it is done. It is finished. Those are our 6 trig functions. Why don't you pause this video and see if you can do this other triangle, triangle FGH, write these 6 trig functions. Welcome back. Here are the answers I got. The first 3 trig ratios right here, and then the reciprocal functions below them. Next question, number 2. Write an equation involving sine, cosine, or tangent that can be used to find x, then solve for x. Here we have our right triangle. We have angle 43, so we're going to use that. We're going to have a trig ratio with the angle theta being 43. Notice what we're looking for. We're looking for opposite of that angle. So whatever trig ratio we choose, it better have opposite in it. Oops. And then also we are given 11, and that's the hypotenuse. So if you label them like this, you should be able to tell you have O, you have H, so katoa, that would be the sine ratio. You'd want to write the equation as sine 43 degrees equals the opposite, which is x, over the hypotenuse, which is 11. Now to solve this, sine 43 is just some number on your calculator. Make sure you can find the sine button on your calculator. You probably already know where it is. But we're going to multiply both sides by 11 to move this 11. So this will be 11 times sine 43 degrees equals x. To calculate this, 11 times sine 43x. When I do sine 43 on my calculator, I get this value, 0.681998. equals x times 11. So it looks like the answer you should get is 7.502. That would be the length of this side. It does make sense in the context. It should be less than 11. 11 is the hypotenuse. And 7.5 sounds about right. It shouldn't be too small because the sum of the three sides of the triangle, or the sum of the two smaller sides, should add up to be bigger than the hypotenuse. But 7.5 makes sense. I do want to caution you, some calculators are set to the wrong mode. So let me show you with Desmos. We have 11 times sine 43. If I go to Desmos that I have all set up for you, over here on the left I'm going to type 11 times sine 43. And then right here we get the answer of negative 9.149. Negative is definitely not right. This is a length of a triangle side, so no good. It is less than the hypotenuse, but it's negative. The problem here on Desmos is that the mode that it's set in is on radians. In a lesson soon we'll talk about radians, but down here at the bottom it says degrees. You need to click on that. See that? Radians, degrees, radians, degrees. And as I'm clicking back and forth, you can see the answer on the left again. When it's radians, it's negative 9. When it's degrees, it's, oh yeah, that looks familiar, 7.502. So on your calculator, you might need to change the mode if you got that negative answer, if you got negative 9. Or find someone near you that can help you find the mode. It's usually under mode. It would be rad. Rad is radians. Deg is for degrees. We will talk about what radians are. It's a different way of measuring angles instead of using degrees, but we'll save that for later. Pause this video, see if you can write the equation on the second one on number 2, and also solve for x. Go ahead and pause this video. The answer I got was 6.928, and that is a leg, not the hypotenuse. So it should be less than 8, and that makes sense. It is less than 8. Now you might have noticed, you might have attempted to use what you learned in Math 2 or Geometry, the 30, 60, 90 pattern. The 30, 60, 90 pattern, to remind you, opposite of 30 is n. The hypotenuse is double that, 2n. And the side opposite of 60 is the weird one. It's n times the square root of 3. So this would tell us that opposite of 30, this side would be a 4. This is 8, double that. And this number that we got as an answer, that must be 4 root 3. If you type on your calculator 4 times root 3, we get, eureka, 6.928. So there's another approach you could have used for this if you remembered that pattern. Now you might wonder, do I really need to know that pattern? And my answer would be, turn the next page. Turn the page. Turn the next page. Turn the page. Here are two incredibly common, frequently used patterns in trigonometry. You definitely want to memorize these, particularly when you get to a couple lessons from now. If you have these memorized, it will make your life much easier. And in Math 4 pre-calculus, you'll use these patterns some more. In AP Calculus or Calculus, you'll use these patterns some more. And on standardized tests like the SAT and the ACT, they often use patterns like these. They show up quite a bit. The 45, 45, 90 pattern is basically based on a square. You have an n and an n. If you were to use the Pythagorean theorem to find this side, or this diagonal, you would get an answer of n root 2. The pattern here would be these are the 45-degree angles, 45, 45, and the 90-degree angles already labeled with a little rectangle in the corner. Opposite of the 45s are congruent. It's an isosceles, right triangle. And this side would be n times the square root of 2. So I would recommend knowing that pattern, that you'd be able to reproduce that pattern right there. And the 30, 60, 90 pattern we've already labeled. Why don't you pause the video and see if you could fill in the blanks, and then you can check it momentarily. I chose to put the 60 at the acute angle at the bottom of the right triangle since it was more drawn to scale. So this is the pattern that I have. However, if you chose to put the 30 at the bottom, it's not really drawn to scale very well, but just notice that I've switched the n root 3 where the n root 3 was over here. So either one of these would be acceptable. The one on the left is probably better since it's more drawn to scale. This formula comes from an equilateral triangle. Erase. If you have an equilateral triangle, let's call this side 2n, this side 2n, and this side 2n. It is equilateral. If it's equilateral, all the angles are the same. They're all 60. This one is a perpendicular bisector. It cuts the angle in half, 30 and 30. So notice here's our 30, 60, 90 pattern. Here's our 2n. This side's been cut in half, so this side is n. And if you use the Pythagorean theorem, you could find this question mark, this altitude. So if we did that, we'd have n squared plus question mark squared equals 2n in parentheses squared. That would be a 4n squared equals, subtract n squared from both sides, question mark squared. So that would give us question mark equals plus or minus the square root of 4n squared minus n squared is 3n squared. It's a length, so we don't want the negative one. So we get a positive root 3 times the square root of n squared is n. So n times root 3. N times root 3. That's where that 30, 60, 90 pattern comes from an equilateral triangle. Now let's go down. Number 3, you're asked to solve for different angles and such. So let us do that. Labeling. Let's see, I will call this A. C is the right angle. C is down here, the right angle. And then B. Lowercase a is the side opposite of capital A, the angle. So 12 goes down here. Lowercase b is the side opposite of capital B. So 5's over here. And I know this is a special right triangle, 5, 12, 13. You can get that by doing the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. So this is a 13. When you're asked to solve the triangle, you're being asked to solve for everything. All we need now is one of the angles. So let's just start with angle A. We know the opposite of A and the adjacent to A given in the problem. So that would be tangent. Tangent A equals 12 over 5. You'll see this tip over here. And you've done these before in geometry or math too. But to solve, you have to isolate the angle A. So you have A equals, you need to do the inverse operation. So inverse tangent, also known as arc tangent. Another name for that. So make sure you hit the second button on your calculator. Second tangent, 12 over 5, is 67.4. 67.4 degrees. That is going to go for angle A, 67.4 degrees. And then to find angle B, we could do 180, the sum of the three angles in a triangle, or we could do 90 minus 67.4. We already have 90-degree angle, so the other two must add up to 90. So that looks like, what is that, 22.6? Yeah, 22.6 degrees. So now this triangle has been solved. get rid of some of this so you can focus. There you go. That triangle has been solved. All three angles, check. All three sides, check. That is a solved triangle. Now, let's move on to the bottom here. We have 4 questions here. Why don't you pause this video, see if you could figure out question number 4. You'll see here in my work I got 55.6 degrees. Also, I'd like to point out the notation that I've used here, the name, arc cosine. Arc cosine is the same as inverse cosine. On 5, 6, and 7, we have some word problems. I'm giving you the picture on number 5. Area run in Snowbird, Utah has an angle of elevation of 20.2 degrees. That would be this angle down here, 20.2 degrees. The length of the ski run, that's the part that you're actually skiing down, the length of the ski run, that would be this part, is 8,400. You want to find the vertical drop. The vertical drop would be this side, is x. See if you could write a trig function and solve it to find the vertical drop. The answer should be less than 8,400, which is the hypotenuse. Go ahead and pause. So I used the sine ratio. I was given the angle, so I didn't have to do inverse sine or arc sine. Just type it right like that. Sine of 20.2 times 8,400. I got, it's a vertical drop of 2,900 feet, so about a half a mile vertical drop. The next question, number 6, we have a ladder leaning against a wall, forming an angle. Definitely want to include a diagram here. So let's see, here's the ground, here's the wall, and we're assuming the wall is perpendicular to the ground. Good construction. The ladder, I'll go like this. There's the ladder. Very crude looking ladder. The ladder leaning against the wall makes an angle of 74 degrees with the ground. So the green line with the red line ground is 74 degrees. If the foot of the ladder is 6.5 feet from the wall, so the wall is here, foot of the ladder is here, so this length is 6.5 feet. 6.5 is down there. How high on the wall? So x. What is this length? X. Go ahead and pause and see if you can choose the correct trig ratio. I got 22.67 feet, so it's about 23 feet up on the wall. Number 7, see if you can draw the diagram for number 7. Pause, and when you come back, I'll have the diagram but not the answer yet. That's what I have so far. Ground, airplane flying, that is an airplane. 11 degrees, just have to figure out where to label the variable x and where 10,000 feet goes. There we go. 10,000 vertical feet. The ground distance is what we're looking for, so that would be along the ground. See if you could figure out what trig ratio to use. Pause this video. You should have chosen the tangent ratio. Tangent 11 equals opposite over adjacent, 10,000 over x. We haven't seen one like this in this video, but you have seen them before in a previous math class. Whenever the variable's in the denominator, there's a couple approaches you can take. I usually just think of it as multiply both sides by x to get rid of that x from the denominator. So now we have x tangent 11 equals 10,000. Tangent 11 is just a number, so we'll divide both sides by that tangent 11. So the x is going to be left there, x, and it's going to equal the 10,000 that's been sitting around there from the beginning, divided by tangent 11. And you would type it like that, 10,000 divided by tangent 11. And that is 51,445.5. And I ran out of space. So round to 6. 51,000 feet is the vertical ground distance, or approximately 10 miles. So by the time the plane has reached 10,000 feet, it's gone 10 miles along the ground. Be careful that you know how to solve ones like that whenever the x is in the denominator. Now you could have used cotangent 11, but there's really no cotangent button on your calculator. You would just, on your calculator, do 1 divided by tangent 11 would equal x over 10,000. And that would work. I don't find many students who like to do it that way. But visually you can see if you multiply both sides by 10,000, then you would just have something like that. 10,000 over tangent 11. So you could set it up as a cotangent, just there's no cot button on the calculator. You'd have to know that it's the inverse, or the reciprocal, 1 over tangent. Lastly, number 8, pause this video, see if you could figure out what the diagram might look like. When I started to try to draw this, I tried having a river. Here's the river card. Here's the river. I tried having a north-south river, but then I read this statement 50 meters to the left of the stake, like over here, and I got confused, so I thought, oh, maybe I should rotate my river. So I got, now the river is here going east-west. I started with this plot and this plot. Those are the plots, or the stakes that are opposite of each other. And then I went 50 meters to the left. So that was over here. And then the 82 degrees is measured between the two first stakes. So that would be the 82 degrees. So I believe this would be the correct model representation of this situation. And we're looking for the distance across the river, and that would be x. It looks like we would use the tangent ratio. Tangent of 82 degrees equals x over 50. So we'd have 50 times tangent 82 degrees equals x. So our final answer for the lesson, 50 times tangent 85, whoops, caught that mistake, didn't I? Where in the world did 85 come from? 82. Must have been thinking of 50. 50 tangent 82 degrees is 355.77. So it's approximately 356 feet, so a little more than a football field in length. Thank you for watching this video. Hope it was helpful. Enjoy doing your homework and enjoy your day.